Howdy. How you guys doing? Here's what we're aiming for. A test on chapters 4 and 5, because that's exponents and logs, which are inverse functions of each other. Aiming for it on 3/27, March 27th at 3:05. It'd be great if everybody could take it at the same time, so I don't have to worry about it, but I will adapt. If somebody wants to take it earlier, it's fine with me, but they'll be taking a different test from this day, because I don't want it to be one of these things where somebody took it early and told everybody else, here's what's on it. I don't think any of you would do that, but I want to play it that way. And before we do anything else, check it out. I get a haircut, my annual haircut, and that's all the news. That, you know, that's all I've got. So here's what you have to know and understand. These two rules over here, we're going to use them over and over again today. We've seen them. We had a quiz on using logarithms. And here's this one move, very handy to get this m out of the exponent position. So you got to know those two rules. We're going to be using them like every problem. All right, so here's some example problems. Notice that we have, and this is right out of the book, log to the base b of b to the sixth. So you can't do it on your calculator, or can you? You have two log buttons on your calculator. One of them, the base is 10. So you could do on your calculator, I'm writing it ghostly style, log to the base 10, that's what's on your calculator, of 10 to the sixth. You could input that on your calculator, hit enter, and it'll give you a 6. That's what will happen. But I don't even know if that's picking up on the camera. It's so faint. What you're actually supposed to know is that the log to the base b and b to the sixth are inverse functions. So all that's left is the 6. The answer is 6. Or you can think of it like this. The power I would put on b to get b to the sixth. Oh, I put a 6 on b to get b to the sixth. You can think of it like that. But either way, you got to have some way to work through that problem. Now this guy is not so hard when you look at it the way we just said. What power would you put on 3 to get 27? You would put 3. 3 to the third is 27, because that's 3 times 3, which is 9, times 3 is 27. So 3 to the third is 27. So the power I would put on 3 to get 27 is 3. So this entire thing here is worth a 3. Now, what power would you put on 3 to get 3? I would put a 1 on 3 to get 3. So that answer is just a 1. Next one, you're supposed to recognize that as a fractional power. They beat fractional powers into the ground in the first part of chapter 4. So this is log to the base b of b to the 1/5. And by the same thinking that as that one, these two functions undo each other, and I just get the 1/5 for the answer. And like I advised before, now if you don't know what to do with this, try on your calculator log to the base 10. Your calculator won't write the base 10, and it's going to be 10 to the 0.2. That's what 1/5 is. And you hit enter, you'll get 0.2. So you know the power comes down. The power is the answer. So you can get that 1/5 or that 0.2 full credit that way. But the book and I would like you to know that these, this piece right here and this piece right here are inverse functions, and they undo each other. So what's left? Just the 1/5. All right, so you got to be able to do that kind of thing, especially with the log base being a b, because it makes it look like you didn't use your calculator. It makes it look like you knew how to do the rules, like you knew what the math was for. All right, so the book gives 3 examples, and they're all world famous: pH, decibels, and earthquakes. So the Richter scale for earthquakes has the formula given in the book. The decibel thing has the formula given in the book. And pH has the formula given in the book. Don't memorize them, but be able to use a formula that has logs in it. So this one's famous. This is the amplitude of your earthquake, measured in comparison to, this would be kind of a minor earthquake, maybe something just barely shakes the glasses in the cupboard. So if your earthquake was 1.6, let me get that sub-zero in the right place. If your earthquake was 1.6 times 10 to the sixth bigger, so in other words, more than 1,000,000 times bigger than this minor earthquake, and this idea like 1,000,000 times bigger, but think about something that just shakes the glasses is a pretty small earthquake. It's still a very powerful animal because you're moving a big piece of earth. But something that's splitting the ground open and knocking down buildings, that's a much more powerful thing because it's moving the earth further. It takes a lot of force to move that much of a tectonic plate. So how do you compare these guys? Well, you do what the formula says. You have log of 1.6 times 10 to the 6th, a sub 0, divided by a sub 0. Well, the a sub 0 is canceled by division. That's perfectly legal. And now you're just taking the log of 1.6 times 10 to the 6th, which I did in my calculator, comes out to be 6.2. So this earthquake is 6.2 on the Richter scale. And that's how it works. You just do that thing. It's not so bad, and I'm definitely going to ask you about it. So be able to do Richter scale for sure. But in real life, you should be able to handle any formula, relatively simple, nothing too fancy, that has a logarithm in it. All right. Got a few more problems for you. You got to be able to solve. You got to be able to solve. And it's problems like 8 equals 3 to the 7x minus 1. Problems like log to the base 2 of x equals 3. And a problem like 3 log of 4x plus 1 equals 9. So you got to be able to handle these three kinds of things. Let's start from the left. When you have x in the exponent position and the base isn't a 10 or an e, then it doesn't matter what log you use, but you're going to use a log because a log of something with an exponent allows you to bring the exponent down. Why do we want to bring the exponent down? The problem is talking to you, is it not, Greg? You want to solve for x. You want to get that x where you can have it, x equals. But x is in the exponent position. So if you know this log rule, you know that will bring the exponent down into a place where I can actually use regular algebra rules. Okay, so we're going to take the log of both sides. And it doesn't matter what base, so I'm going to use base 10. Log to the base 10 of this. And now, Carly, can you answer what's going to happen with this 7x minus 1? Wow, just like in class. Nobody talks to the old man. Log to the base 10, unwritten base, log to the base 10 of 3, but that 7x minus 1 is now downstairs. And this is just log to base 10 of 3. Log of 3 is just a number. I don't even care what that number is. It's just a number. So it's like having a 5. We'll divide by that. I'm just going to divide by log 3. You're allowed. And what you get is you now have log to the base 10 of 8 divided by log to the base 10 of 3, and that's equal to 7x minus 1. So add 1 and divide by 7. So x is equal to, add 1. So this thing here, it's just a number with a very long name, but it's still just a number. That plus 1, and the whole thing times 1/7 because I divided by 7. And that's what x is equal to. That's your answer. Pretty wild, huh? It's not so bad. Now this guy, I'm going to erase over here because I'm going to work that way. This guy we're solving for x and it's buried inside of a logarithm, but it's not so simple as this one. Let's compare these two. We'll do this one next and then that one. Here's x inside of a logarithm, but there's no other stuff. I just got a base, the x, and this 3. That's this guy. This is the same as saying 2 to the 3 is equal to x. In other words, x is 8. And I'm done. I wish I could do that over here. But I've got an additional factor of 3 before I can undo the logarithm. So we're going to do this one. But take a look at it. Think about it as I erase. So what do you think, Stephanie? What are we going to do first? Did you say divide by 3? Stephanie, very good. We're going to divide by 3 because I have a 3 times a big mess equals a 9. So division by 3 gives me log of 4x plus 1 equals 9. And now I can do get rid of the logarithm because this is log to the base 10. So this is the same as saying that 4x plus 1, oh sorry, this is 9 divided by 3. That's a 3. This is 9 divided by 3. Remember, I divided by 3. Thanks for catching that mistake there. Good job, Margot, catching that mistake. Thank you. All right, so 4x plus 1 is not 3, it's 10 to the 3. Because I'm doing the same step that we did before. I have a log to a base of a quantity equals 3, so it's the base to this number equals 4x plus 1. So 4x plus 1 equals 1,000. And now subtract 1. 4x equals, subtracting 1, that's 3 nines. And I divide by 4. X equals 9, 9, 9 divided by 4. Oh, we could check. And it's a calculator problem because it's a base 10. Nice. I can, in fact, leave off the 3's. If you don't mind, I'm just going to check this thing. Because I don't think I got the division by 3 wrong. Yeah, I just divided by 3. So on the calculator, I'm going to try, just to see if I'm right, I'm going to try the log of 4 times 999 divided by 4. Those 4's cancel. And then plus 1. So you can see it on the screen there. Let's see if we can get it to show up. Give it a second. Give it a second to get the contrast. Come on, buddy. It's not doing it for me. It's just staying bright. That's too bad. Well, typed it in, and of course it comes out to be 3. So this thing does check. When you put this answer right in that spot, the 4's cancel. I add 1, I get 1,000. Log of 1,000 is 3. It works. So you got to be able to do that kind of stuff. You got to be able to do those animals, and I think that's all I have for you today. Remember the goal. Work toward that goal. I'm going to be, as you said, you're going to get a little PDF of my scheduling. I'm going to be checking my emails every day. Send me an email if you ever have problems, questions. I'll deal with them in another video. I'd like to do a couple of these a week for you, maybe 2 or 3. Bye.